Okay, so I started back at this slide here because of the fact that I want to show you some exceptions to this. Okay, so we did all these, and we had two of them that were the transition pluses. Well, transitions at least. They were the manganese and the copper. Okay, but we did one back when we did the ion examples of one that wasn't that. I think the one that we did at that time was CaSeO4, where I had given you calcium 2 plus and SeO4 2 minus. Basically, the 2 plus and 2 minus cancel each other, and so there's nothing there. Okay. Now for this one, it doesn't matter because calcium is a main group. So the name of this one is just calcium selenate, ATE. But it could matter when I'm dealing with a transition plus. Okay. So for example, if I have change colors here. If I have CrPO4, okay, what's the charge on that chromium? Okay, well, I know that PO4, that's why I said you have to know not only the element and the name, but you also have to know the charge. So if that's 3 minus, then the chromium must also be a plus 3 in order to neutralize that. So the name of this is chromium 3 phosphate. So how do I do this here? Okay. Another example is PB parentheses SO4 parentheses 2. Okay. I know because PB, which is right here, is in group 4A that it could either be a plus 4 or plus 2 charge. So how do I know? Okay. So I came up with a formula that I'm going to show you here. Okay. All right. And so this one's going to fit there. Okay. That if I have X, A, Y, B, and charges of C and D. If A is equal to D, then C is equal to B, okay, but positive. That's important. The leftmost is always positive. See, that's positive, okay? So in this example here, okay, this didn't actually equal that. I'm sorry. This is not this example. This is this example here. Sorry. Okay. All right. The other way of doing this is, again, if I go to X, A, Y, B, again with C and D, but this time if A does not equal D, then C is equal to B times D, okay? And so this, I'm sorry, this is an example of this, okay? So therefore, you see that this was a 3, and this is not a 3. So it's 3 and 1 here, okay? So because there's no parentheses, the subscript around this whole PO4 is 1. So 1 times 3 gave me the plus 3 for this. So we said that this was chromium, I erased it already, 3 phosphate. Okay, so what about this one here? Okay, kind of running out of room. Okay, so sulfate is a 2 minus charge. Okay, but there's no 2 down here. So 2 times 2 gives me 4. So that means that this is lead 4, and this is sulfate. Okay. So just because I don't have subscripts down here, okay, doesn't mean, or even if I do, that the charge may not necessarily be that subscript. Okay. So the book didn't give you examples of those, but I made those up. All right. So now let's go in the opposite direction. I give you the name and ask you what the chemical formula is. To me, this is a little bit easier. Okay. So sodium thiosulfate. So sodium is here, okay? And I can tell you it's a main group element because of the fact that it doesn't have the charge written here like that one does, okay? So this formula for sodium is Na, and it's a +1 because it's in group 1A. Thiosulfate is one of those that you have to memorize, S2O3, and because sulfur is a 2-, because it's in group 6A, 6 minus 8 gives me -2. It's also a 2-. So now basically it's just like the problem we did earlier, the fact they crisscross, so it becomes Na2S2O3. So to me this is a little bit easier in this direction, okay? Copper 2, so this already tells me that this is Cu with a 2+ charge. Hydroxide's another one of those that you need to know the name of and the charge, so it's an OH-, okay? It crisscrosses. This is one of those polyatomic ions though, so I need parentheses. So it becomes Cu, it's a U, OH, 2. Okay. For the next one, calcium, there's no name there, so calcium, let me switch colors. So calcium is here. Oops. Push the wrong button. Calcium is here. Okay. So Ca has a 2+ charge. Carbonate has a 2- charge, but I put the hydrogen in front of it, so it becomes HCO3 because carbon's on the 7. So CO3 is 8, and it was a 2- charge, so it becomes a 1-. So this becomes Ca. Again, this is a polyatomic ion, so I need parentheses. HCO3, 2. Okay. All right. Actually, I did this example on the previous page, but that's okay. So chromium is Cr. It tells me that this is a 3+ charge. Phosphorus is over here. It's not on my 7, so therefore it is 8 is 4 oxygens, so it's PO4. Phosphorus is a group 5A, so 5 minus the 8 gives me -3. So also phosphate is a -3. So here's 1, 3 plus 3 minus, so it just becomes CrPO4. Okay? And so that's how you do ionic compounds going both directions. And you will be expected to know how to go both directions. And this is the end of that video.